Covalent bonding. Covalent bonding is the type of bond that you find when nonmetals react together, as nonmetals tend to share electrons and form what is called covalent bond. Each covalent bond will provide one extra shared electron for each atom. The covalent bonding, there is a strong electrostatic interaction between the negatively charged shared electrons, which are the bonding pair, and the positively charged nuclei of the atoms involved in forming the bond. So covalent bonding is a share of a pair of electrons between two atoms. We can draw the covalent bonding using the dot and cross diagram as we've done before with the ionic bonding. In covalent bonding, the shared electrons will be drawn in between the two atoms. There will be no transfer of electrons between the atoms to form ions. So if we have something like fluorine, fluorine is one of the nonmetal group 7 elements. It has 7 electrons in its outer shell. So for fluorine to get the full outer shell with 8 electrons, it would need one extra electron. That extra electron it can take from another fluorine atom to form fluorine F2, which is the diatomic molecule for fluorine. In this case, both of the fluorine atoms, each of them will share one electron to form a covalent bond. These are the two shared electrons, and when you count the number of electrons for each atom, you include the shared electrons. So now each atom has 8 electrons in its outer shell. Fluorine, we can also draw fluorine or draw the structure of fluorine using the displayed formula where the covalent bond is represented with a line. So F and then F, this is the displayed formula for fluorine, which shows a single covalent bonding between two fluorine atoms. Sometimes we atoms would need more than one pair to share. So when we have something like oxygen, oxygen normally exists as a diatomic molecule, so O2. And in oxygen, there are 6 electrons in the outer shell. For oxygen to reach the full outer shell, it would need 2 extra electrons. In order to do that, each atom of oxygen would need to share 2 electrons. So in total, we're going to have 2 pairs of shared electrons. Each pair will represent one covalent bonding. So now when we represent the dot and cross diagram, the first oxygen electrons are represented with the dots and the second one with the cross. As you can see, there are 2 pairs that have been shared between the 2 electrons, and now we can draw the 2 covalent bonding using the 2 lines, so between the 2 oxygens. So there are 2 lines here which represents 2 pair of shared electron, each one with one covalent bond. If we look at nitrogen, another diatomic molecule, nitrogen has a 5 electron in its outer shell, which means each nitrogen would need 3 extra electrons to reach the total of 6. It's one of the group 5 elements. And now to do this, each nitrogen would share 3 electrons. So there will be, in total, there will be 3 pairs of shared electrons or 6 electrons. Each pair will represent one covalent bonding. So the 2 nitrogens will have a triple bond or 3 covalent bond in between them. So to represent it using the displayed formula between the 2 nitrogens, we have to draw all the 3 bonds, covalent bonds as 3 lines. We can also see covalent bonds between in molecules of compounds, not just for elements. For example, for water, so both hydrogen and oxygen, they also share electrons to form covalent bonding. So when you have a molecule of water, hydrogen will only share one electron with an oxygen. but the oxygen would need two electrons. So oxygen will react with two atoms of hydrogen. With each atom of hydrogen, there will be one shared pair of electron, and that represents one covalent bonding. So if you want to draw the displayed formula for water, you have to put the oxygen with two different covalent bonding with two different hydrogen atoms. You can practice drawing these covalent bonding with any structure that has covalent bonding, usually the ones which have non-metals, so anything like organic molecules, something like carbon dioxide, and so on. So you just need to count the number of electrons that each atom would need to reach the full outer shell and start drawing the number of electrons that would be shared.